Hi, my name is Patrick Reagan. Welcome to the Basic Network Hardware series, where we discuss networking topologies, appliances, applications, and functions. The first video, Basic Networking Topology, will discover the network topologies used in today's networks. Topology describes the appearance or layout of the network. Understanding the network topology is useful in planning a network, and understanding how a signal flows through the network will help in troubleshooting problems. Topology can be divided into the physical topology, which is part of the physical layer, describes how the network actually appears. The logical topology, which is part of the data link layer, describes how the data flows through the physical topology or the actual pathway of the data. While the physical topology is easy to recognize, the logical topology is not. The physical and logical topologies are not always the same. All physical topologies are variations of two fundamental methods of connecting devices: point-to-point and multi-point. Point-to-point topology connects two nodes directly together. In a point-to-point link, the two devices monopolize the communication between the two nodes. Because the medium is not shared, nothing is needed to identify the two nodes, although some implementations may use addresses. Whatever data is sent from one device is sent to the other device. Multi-port connection links three or more devices together through a single communication medium. Because multi-point connections share a common channel, each device needs a way to identify itself and the device to which it wants to send information. The method used to identify senders and receivers is called addressing. Network cards connected to a network are identified with their physical addresses or media access control or MAC addresses. A bus topology looks like a line where data is sent along a single cable. The two ends of the cable do not meet, and the two ends do not form a ring or loop. All nodes, devices connected to the computer including network computers, routers, and network printers, listen to all of the traffic on the network, but only accept the packets that are addressed to them. The single cable is sometimes referred to as a segment, backbone cable, or trunk. The bus topology was used in early local area networks, which uses coaxial cable as the bus. While the design was simple, one break in the bus can disable the entire network. A ring topology has all devices connected to one another in a closed loop. Each device is connected directly to two other devices. Typically in a ring, each node checks to see if the packet was addressed to it and acts as a repeater, which duplicates the data signal, which helps keep the signal from degrading for the other packets. This, of course, allows the network to span large distances. While a token ring cannot be found anymore, rings are still used in many metro area networks, or MANs, and wide area networks, or WANs. Many of these designs will use dual rings to provide built-in fault tolerance. A star topology, also known as hub and spoke, is the most popular topology in use. It has each network device connected to a central point, which acts as a multi-point connector, forming a hub and spoke. It is used in most large and small networks, and it requires more cabling compared to most topologies, except mesh. The central hub or switch can be an expensive component, especially in large networks. However, the central hub or switch makes it easy to manage the network and troubleshoot issues since the hub is a central point for all traffic for the topology. Network administrators can monitor and control network traffic more effectively. A break in one cable will only affect the one device that the cable connects. Today, most are switched Ethernet networks where a switch is the central point. Unfortunately, since the central point or switch is a critical component, if it fails, the entire network goes down. Redundancy and backup solutions for the central device can mitigate this issue, but that adds complexity and cost. The mesh topology has every device linked to every other device. While this topology is not very common in LANs, it is common in WANs where it connects remote sites over telecommunication links. This is, of course, the hardest to install and reconfigure since the number of cables increase geometrically with each computer that you add. Some networks will use a modified or partially connected mesh topology, which has multiple links from one computer to another, but doesn't necessarily have each device linked to every other device. Another topology worth mentioning is the cellular topology. Different from the previous topology, this one is based on wireless technology instead of wired technology. Cellular technology is a type of network topology used in cellular networks where the service area is divided into smaller geographic areas called cells. Each cell is served by its own base station or cell tower, which communicates with mobile devices within that cell. The main goal of cellular topology is to provide wide area coverage and support a large number of users by reusing frequencies efficiently. As a mobile device moves from one cell to another, the call or data session is handed off from one base station to another seamlessly. A dead spot occurs whenever there's distance or obstructions between you and the cell tower. Essentially, it is an area where there is no signal. Here's a summary of the common wired topologies found on today's networks. The bus and ring are easy to install, while the star is easy to install but is time consuming because you have to use a cable for each device connected to the central point. The mesh is the most difficult because it requires the most cables to connect. Of these, the star is easy to add a new system where you just need a single cable to connect the new device to the central point. For troubleshooting, a break in the single bus or ring will prevent transmission. For the star topology, a break in the cable will only affect the one device that it connects to. However, if you lose the central point or hub, your network does not function. The mesh is the most redundant and is easy to troubleshoot. The hybrid topology combines two of their traditional topologies, usually to create a larger topology. The hybrid topology allows you to use strengths of the various topologies to maximize the effectiveness of the network. Three common examples of the hybrid topology would be bus star topology, which has multiple star networks connected using a central bus backbone, which you may find in enterprise networks, especially with switches. Star ring topology, whereas each star network is connected in a ring formation to combine multiple star networks to a redundant ring. Tree or hierarchy topology has multiple star networks are connected in a hierarchy structure similar to a tree. Most networks are hybrid unless it is a small standalone network. An office building might use the star topology within each department for easy management and troubleshooting, while connecting these department networks using a bus or ring topology to form the overall network. This setup allows for efficient data routing. This figure has a bus link that forms a backbone connecting the various star topology. This figure shows a ring, which is commonly used to connect multiple switches together with the redundant links between the switches. Sometimes the topology may not be as obvious. Here's an example where multiple switches are combined to create a larger array of ports by connecting the switches using a ring topology. The servers and PCs will be connected to the ports to form a star topology. Data centers frequently employ hybrid topologies to manage the complex requirements of servers, storage systems, and networking equipment. For instance, a data center might use a mesh topology for the core network to ensure high availability and redundancy, while using a star topology for connecting individual servers and storage devices to the core network. Universities with multiple buildings and campuses often implement hybrid topologies. Each building may have a star topology network connecting all classrooms and offices to a central switch. These central switches in different buildings are then interconnected using a ring or mesh topology, providing robust connectivity and failover capabilities across the campus. Ethernet is a widely used technology for local area networks, enabling devices to communicate with each other through a common network medium. Ethernet is a foundational technology for wired networking, providing reliable, high-speed communications for a wide range of devices and applications in both residential and commercial settings. It defines both the physical and data link layers of the OSI model for wired networks. It was developed in the 1970s by Xerox PARC and later standardized by IEEE as IEEE 802.3. The original Ethernet was a coax bus topology, logically and physically. While today's Ethernet devices connect to a switch to form a physical star topology or hub and spoke topology, the logical topology is a bus. Each cable connected to the device to a hub or switch would have a send and receive pathways, and the bus will be formed in a hub or switch, which would create the two ends of the bus. Question: which of the following network topologies contains a direct connection between every node in the network? Answer: mesh. Question: which of the following topologies requires the most connections when designing a network? Answer: mesh. Question: which of the following network topologies best describes a central device connected to multiple independent devices? Answer: hub and spoke. Question: today, which of the following is the physical topology for an Ethernet LAN? Answer: star. Question: you have 5 devices connected with cables using a hub-spoke topology. How many devices cannot communicate if one of those wires go bad? Answer: 1. Question: you have 5 devices connected to a bus topology. How many devices cannot communicate if a cable goes bad between computers 1 and 2? Answer: 5. Remember, if the bus topology breaks, it affects the entire network. For more information, refer to these sites. In summary, topology describes the appearance or layout of the network. All physical topologies are variations of 2 fundamental methods of connecting devices: point-to-point and multi-point. A bus topology looks like a line where data is sent along the single cable. A ring topology has all devices connected to one another in a closed loop. A star topology is the most popular topology in use, where it has each network device connect to a central point that acts as a multi-point connector, forming a hub and spoke. The mesh topology has every device linked to every other device. Cellular topology is a type of network topology used in cellular networks where service areas divide into smaller geographic areas called cells. The hybrid topology combines two of the traditional topologies, usually to create a larger topology. Thank you for watching this video. The next video will be Basic Networking Hardware, Part 2, Connecting to a Network. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.